Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can solve polynomials. Now, this is a review of some of our other videos, so if you want a video on how to specifically solve by factoring or solve using the rational root theorem, then please check out one of the previous videos. In this one, we are just going to review how we can solve different types of polynomials depending on how we come across them. Now, there are some important things to keep in mind when it comes to solving polynomials, and that comes into play with the fundamental theorem of algebra. So the fundamental theorem of algebra says if you have a function that's a polynomial of degree n, where the n is greater than 0, so a positive degree, then the equation, when set equal to 0, has at least one solution in the set of complex numbers. Now remember, a real number is a type of complex number. So the corollary of that is that if we have a function that's a polynomial with a positive degree, then the equation, when set equal to 0, has exactly the same number of solutions as the degree of the polynomial. So that means that if we have a degree of 3, we have 3 solutions, 2 solutions, things like that. And so it's going to be that way. If we have like 3 zeros, those count as 3 unique solutions for those 3 answers. Now, there are some terms that are going to be thrown around. So remember, a polynomial function is a function that contains a polynomial, and a function is something that only has one y value for every x. And then when we talk about factors, what we're referring to is this idea that we're breaking it down into its pieces. And then after factors, whenever they ask you to find zeros, x-intercepts, roots, or solutions, really what they're looking for is when I set it equal to 0, what are the answers? And so zeros or x-intercepts or solutions all come out that way as x equals something rather than x plus something equals 0. So let's take a look at some of those properties of these polynomial functions. Now, remember, if we're graphing them, as a quick review, if there is a multiplicity of 1, so we just have like x equals 1, then what's going to happen is we are going to go through at that point. If there's a multiplicity of 2 or any even amount, it's actually going to bounce. And then lastly, if we have a multiplicity of 3 or any odd amount, what it does is basically what our function's doing is it comes up to our axis. If it's just 1, it'll go straight through. If it's 2, it kind of like wants to go through, but then decides not to and comes back out. Imagine it goes through once and then back through again. Now, when there's 3, what it's going to do is it's going to go through once, like this. Then it's going to want to come back, but then it actually decides it wants to go through. And we call that motion of coming in, kind of hesitating, and then coming back out a flex. Because what it's trying to do is decide, do I want to go through or do I want to come back out? Now, with an even number, that space is going to get wider the more multiplicities we have of something. So when it's a 2, it just hits and comes back off. But when it's a 4, it's a little bit wider. So that's what these different graphs will look like there. Now, what we want to do is use this idea of repeated solutions, things like that, to solve polynomials. So let's take a second to solve these polynomials. Now remember, every time we solve a polynomial, the very first thing we want to do is factor out the greatest common factor. So let's take a look at this first example here. I'm going to factor out our greatest common factor, and in this case, that's going to be 5x. So I factor out 5x, and I get x squared minus 8x plus 16. Okay, so then what we can do is we can go, and our second step is to try to factor. So we want to ask ourselves, does what's left over factor? Well, I look at this and I'm going to try my x method. Is there a number that multiplies to 16 and adds to negative 8? Well, I can come up with one, so I'm going to factor here. So 5x, those two numbers are negative 4 and negative 4, times x minus 4 times x minus 4 equals 0. So we either want to factor. If it doesn't factor, that's when we want to use that rational root theorem to then graph it and figure out where those options are. Then our third step is to set each part equal to 0. So when we factor, we're going to set each part equal to 0. And so as we do this, the rational root theorem, we are going to set each of these equal. So 5x equals 0, x minus 4 equals 0, and x minus 4 equals 0. Now notice how we factored them out as much as we possibly could before we set them equal to 0. Now what I'm going to do is solve for x. So this gives me that x equals 0, x equals 4, and x equals 4. Now I can ask myself, are these all the solutions? Well, look, if I have a power of 3, then yes, these are all the solutions. Now let's take a look at this next one. Now let's take a look at one of these problems. So to solve a polynomial equation, remember, it has to equal 0. So we need to make these equal to 0 first before we solve them. So I'm going to actually set this one and make it equal to 0 to start. So I am going to subtract 4 and add 12x from both sides. So subtract 4 plus 12x. Okay, so then as we finish writing this out, what we end up getting is 0 equals negative 3x cubed plus x squared plus 12x minus 4. Now notice how I wrote this in standard form, meaning the highest exponent then the lowest one. That's so important when it comes to factoring. Now, I don't see a greatest common factor between these, so I'm going to try factoring first. There are 4 pieces, so let's try factoring by grouping. So as I factor by grouping here, I can factor out a negative 3x squared, and I'm left with an x plus 1. And here I can factor out a 4x, and I am left, or a 4, and I am left with a 3x minus 1. Well, shoot, can we factor this? No, we can't factor this by grouping, right? Because what's left inside is not the same. So when we can't factor by grouping, what we're going to have to do is that rational root theorem. So what that rational root theorem means is instead of rewriting it like this, what we're going to do is I'm going to eliminate this line where I decided to graph it. I'm going to get rid of these blue pieces here. And we are actually going to use our rational root theorem. So what that rational root theorem means is that I'm going to take the end number, or the constant, and divide all of its factors by the factors of our first number. So the factors of 4 are 1 and 4, and 2 and 2, and the factors of 3 are 1 and 3. And that's the positive and negative of each of those. So that means what we end up getting is we end up getting plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, and plus or minus 4/3. Now with that rational root theorem, these are all the possible rational solutions that we could get. Now what we want to do once we have these is we actually want to graph our polynomial and take a look at what it looks like. So I'm going to go ahead and type this into my graphing calculator here, and I will sketch a picture of what my graph looks like. So as I graph this in my graphing calculator, what my function ends up looking like is something like this, where it goes through here, and then it comes up, and then it goes back down. Okay, so this here, this point, looks like it is about at -2. This one here looks like it's at +2, but this one here, it doesn't look like it's exactly at something. So I've got a 1/3 option, a 2/3 option, and a 4/3 1/3 and 2/3 that's between 1 and 2, which is what it looks like on my graph. So I'm going to try 1/3. Now there's 2 different ways we can decide. We can either say it looks like it's 1/3, so let's try it, or we can do synthetic division, or after we do some synthetic division, we can solve for it. So I'm going to do synthetic division with my 3 solutions. So I'm going to try -2, +2, and I'm actually going to try +1/3. So remember, if we do synthetic division with these, as long as we get a remainder of 0, then we know that it's one of the solutions. So I'm going to start with 2, and I've got -3, 1, 12, and -4. So let's do this synthetic division here. So -3, 2 times -3 is -6. That gives us a -5. This will give us a -10. That gives us a 2, 4, 0. Perfect. So I know that x equals 2 is one of my solutions. Now I'm going to try another option here, -2. Now notice how here I'm doing what's called stacked synthetic division, so I don't have to restart with the whole problem. This is a great way to limit the amount of synthetic division that we're doing because it reduces the number of terms we have to divide. So I'm going to try with my -2 now, so I get -3 straight down. 6 gives me a 1, -2 is a 0. Perfect, so I know that x equals -2 works. Now at this point I have 2 options. I can either do synthetic division with +1/3 and see what happens, or what I can do is this 1/3 is actually the same thing as -3x plus 1. So what I can do is set that equal to 0 and solve for x. And so in this case, I end up getting x equals 1/3. Now let's try it with our synthetic division, see if we get the same thing. So I bring down my -3, -1, 0. So our solutions here are 2, -2, and 1/3. So that's how we can find those solutions. So again, the process that we're going to follow when we're trying to solve these is we are going to first factor out our greatest common factor. And then after we do that, we're going to give ourselves 2 options. Always first try to factor it. If it doesn't factor, then we're going to use that rational root theorem. Once we've factored it, what we're going to do is our next step is to set each part equal to 0. If we're doing the rational root theorem, what we're going to do here is we are actually going to do synthetic division. We're going to graph first, and then we're going to do synthetic division. So as you're trying to decide what to do when you're solving a polynomial, start by finding the greatest common factor, then try to factor it. If it doesn't work, then use the rational root theorem. If factoring works, then we're going to set each part equal to 0 and solve for x. And solve. If the rational root theorem, if we have to use the rational root theorem, we're going to graph it, approximate where those pieces are, and then use synthetic division to double check. And that is how we can solve a polynomial. So let's take a look at one last example here, and we can decide what to do. So in this case, what we're going to do is remember the very first of our chart is the greatest common factor. So let's factor that out. In this case, it's an x to the third. So we get negative 2x squared minus 7x plus 4. Now the next thing we're going to do is we're going to try to factor it. And if factoring works, awesome. If not, we'll do the rational root theorem. So let's try both. I always like to try factoring first because factoring is easier, but you can always do the rational root theorem and it'll never be wrong. So I'm going to factor this using my x method. Remember, we have to multiply these top two. So negative 8, negative 7. I can think of a pair, negative 8 and 1. But because I multiplied by negative 2, I need to divide both sides by negative 2. So this one simplifies to 4. This one becomes 1 over negative 2. So it factors into x to the third times x plus 4 times negative 2x plus 1 equals 0. Perfect. Then what we have to do, remember in our factoring stage, is we set each piece equal to 0 and solve for x. So that's what we're going to do, each piece. So this x to the third is really the same as x times x times x times x to the fourth times negative 2x plus 1 equals 0. So whenever we have a repeated x, x squared, x third, x to the fourth, really what that means is that many x's. So when we talk about setting it equal to 0, we need to set each of those parts equal to 0. So in this case, I've got an x equals 0 for the first one, x equals 0 for the second one, x equals 0 for the third one, x plus 4 equals 0, which means that x equals negative 4, and negative 2x plus 1 equals 0, which as we solve out for x, we end up getting that x equals 1/2. So I got these 3 zeros plus a negative 4 plus a 1/2. Now I need to ask myself, is this all my solutions? Well, it's easy to determine if these are all our solutions based on our original polynomial. So remember that fundamental theorem of algebra says that the degree will tell us the number of solutions. So in this case, I solved it as much as I can and I got 5 solutions. Well, according to this polynomial, I should only get 5. So these are all my solutions. Now, just to end this video out, we are going to sketch a picture of this graph using our polynomials here. Again, if we had to do that rational root theorem with synthetic division, we would want to graph it in our graphing calculator. So let's take a look at what this is going to look like. Again, when we graph it, we're going to put a point at each of our solutions. So here's one at 0, here's one at negative 4, and here's one at 1/2. And what's it going to do at each? Well, it's going to go through, and this one is going to flex. So it's either going to look like this or like this. Now, how do we decide which way it's going to flex? Well, that depends on the first number here. Where our first term is negative, we're actually going to be negative on this end. So using that idea, our end behavior there is negative. We're going to go up, we're going to flex through and come back down. So this will go through here, it'll flex through, and then we've got to go back through this one. So overall, our function ends up looking like this, which is pretty awesome. I'm going to kind of adjust this line here, which is pretty awesome. And that is how we can solve a polynomial when deciding what to do. So again, just as a last breakdown, anytime that you are solving a polynomial, here are some great options if we are only looking at polynomial, sorry, talking and spelling can be hard. As we look at solving these polynomials, now this is looking at only rational solutions. What we are going to do is we have 2 options. Very first, we find our greatest common factor. Then after we find our greatest common factor, we're going to break into either 2 groups. We're either going to factor it, or we're going to use that rational root theorem. And remember that rational root theorem says that all of the rational roots can be found based on the fraction or the ratio of the last term and the first term, the last coefficient and the first coefficient. So if we're factoring, what we're going to do is we are going to factor it out. set each piece equal to 0, and solve for x, or solve for the variable. If we are doing the rational root theorem, then what we're going to do is we will graph it, and then use that synthetic division to verify our answers. And remember, when we get that, that means that our remainder needs to be 0 every time. That's how we verify those solutions there. So if you have any questions, feel free to reach out, but that is how we're going to solve polynomials.